Why do irreversibilities reduce Rankine's cycle efficiency? Imagine trying to run a race while carrying a heavy backpack. No matter how fast you run, the extra weight slows you down. That's similar to what happens in a Rankine cycle when irreversibilities occur. The cycle is used in power plants to turn heat into electricity. Its efficiency depends on how close it gets to an ideal, perfect cycle. But real-world factors, called irreversibilities, cause energy to be lost along the way. These losses mean less work is produced from the same heat input. Irreversibilities happen in many parts of the cycle. For example, as steam flows through pipes and valves, friction slows it down and causes pressure drops. This means the steam enters the turbine at a lower pressure than it should, so the turbine can't produce as much work. To keep the cycle running smoothly, the pump has to work harder to push water back into the boiler, which uses more energy. This extra work reduces the net output of the cycle. Heat losses are another big factor. Some heat escapes from the boiler, pipes, and condenser into the surroundings. To make up for this lost heat, the boiler has to burn more fuel, which costs more and doesn't always produce more electricity. It's like trying to fill a bucket with a hole in it. The more heat you add, the more you lose, and the less efficient the cycle becomes. In an ideal cycle, the expansion of steam in the turbine and compression in the pump happen without any entropy change. But in reality, friction and turbulence cause entropy to increase. This means the processes are no longer perfectly reversible, and the turbine produces less useful work. The pump then needs to work harder to compress the water, which adds to the inefficiency. Heat transfer also plays a role. When heat moves between the boiler and the steam or between the condenser and cooling water, it happens over temperature differences. These differences generate entropy and irreversibility. The bigger the temperature gap, the more energy is wasted. The combustion process in the boiler is not perfect either. Some fuel energy is lost due to incomplete combustion and thermal irreversibilities. Similarly, in the condenser, steam condenses at a temperature slightly above the cooling medium's temperature. This temperature difference causes entropy to increase and energy to be lost. All these factors mean that the actual Rankine cycle produces less work from the same heat input than an ideal cycle. To improve efficiency, engineers try to reduce these irreversibilities. They do this by designing better turbines and pumps, improving insulation, increasing boiler pressure and temperature, and lowering condenser pressure. They also use reheating and feedwater heating to make the cycle more efficient. Understanding how irreversibilities affect the cycle helps us see why real power plants are less efficient than ideal models. It also guides engineers in making smarter choices to get the most electricity from the fuel they burn.